As we go on to part 2 of our mini lecture on background information needed for any math course, we're going to take a look at fractions. And here are our objectives: fraction properties of 0 and 1, writing equivalent fractions, writing fractions in simplest form, multiplying and dividing fractions, adding and subtracting fractions, and then arithmetic operations on mixed numbers. And again, many of the vocabulary: whole numbers, least common denominator, often referred to as LCD. So let's get started. And again, as you look at these, see if you already know what needs to be done. Pause, reflect. That's one of the good deals on this. So, a fraction, of course, has an upper part, which is the numerator, the bottom part, which is the denominator. And when the numerator and denominator are the same, we say anything divided by itself, which is what is reflected here, is 1. So 1, by the way, has many different values. Here we're seeing 1, 3 over 3. You could have 4 over 4. You could have 5 over 5. 6 over 6. All of these are 1. Now, the only exception is if it was a 0. 0 divided by 0 is not 1. That is undetermined. All right, now, when the fraction in the numerator, the item is larger than the denominator, we say that is an improper fraction. Now, if the denominator is the same as the numerator, then that is a proper fraction. Or if the numerator is smaller, that is a proper fraction. So, again, how many times does 4 go into 40? And the answer would be 10 times. Now, in a sense, that is 10 over 1. Every whole number has an unwritten 1 underneath it, as we see here. Here, this is 16 over 1, and that simplifies to just 16. This is what it is, but we don't write the 1. Now, if the numerator is 0, but the denominator is a number other than 0, this simplifies to 0. Now here, if our denominator is 0, but our numerator is not a 0, then this is always simplified to something that is not defined in our mathematical system. So we say this is undefined. So again, some of the basic rules for dealing with things in a fractional form. Now, we'll work all of these out over here so we have a little more room. Here we have the fraction 3/10. and we want to make it into a fraction that has a denominator of 40. Now, one of the rules is we could multiply anything by 1 and not change its value. 1 times anything is just itself. So we want to multiply this fraction by 1 so that the denominator becomes a 40. So what form of 1 will we choose over here? These are all forms of 1. And if you said 4 over 4 as a form of 1, that is correct. So 10 times 4 is 40. 3 times 4 is 12. Now the next one is 4 sevenths, and we want it to have a denominator of 56. Well, what form of 1 will we multiply this fraction by to end up with a 56? And if you said 8 over 8, that is correct. 4 times 8 is 32. Now, we're going to do some simplifying fractions here, but notice what we did to convert 3/10 into 12/4. We multiplied it by a 1 in the form of 4 over 4, and this one by a 1 in the form of 8 over 8 to give us this. So we're sort of going to undo this down here. Now, this is going to be 5 times 5 times 2 here. Remember, we can multiply anything by 1, so 5 times 1 is 5, and 5 times 2 is 10. Notice we have formed a new 1 here in the form of 5 over 5, that we can now convert that by canceling out the 5 over 5, because that equals a 1. So to simplify this, we think of it this way, but we can just reduce it to 1/2. Now, in this one, we want to, again, simplify it. Are there 1s there? Well, I know I can take a 3 out of that, and a 3 out of that, and here I'm left with a 3, and here I'm left with a 5. So 3 times 3 is 9, 3 times 5 is 15. If I take out now this 1, which is a 3 over 3, I'm left with a simplified form, 3/5. Now, 1/2 and 5/10 are equivalent fractions. That is, they have the same value. 3/5 and 9/15 are equivalent fractions. They have the same value. Now, as I look at this one, I'm looking for something I could take out. If I took 11 out of there, and I'm left with 8, took 11 out of there, I'm left with a 6. But notice my 8, I could make that into a 2 times, let me erase this here. So I'm just working these out. This will be a 2 times 4, and this will be a 2 times 3. So theoretically I could have taken a 22 out of each of these, and I'm left with 4/3, because this is a 1, this is a 1, 1 times 1 times 4/3. Now there's little shortcuts we can use sometimes. I can see that I could take a 10 out of there by knocking off that 0. So I'm left now with 30 over 55. And I know I can take a 5 out of there and get a 6. A 5 out of there and get 11. So there's my 1 again. So I took a 10 out and a 10 out by crossing out those zeros to get this. And now I'm taking a 1 out in the form of 5 over 5. So my answer here as an equivalent fraction is 6/11. Now notice I simplified this, but I didn't simplify it all the way. This is my final answer. Okay, I'll raise it up and we'll clear this up too. Now, as we go into multiply and then later divide, the basic rules are, as we see our fractions, can we do any cross-canceling, that is, taking out 1s? And the answer is no. So here we just multiply our numerator, which will give me 5, multiply my denominators, which gives me 21. And I have done the multiplication. Now, for this one, and I'll write it over here. So this is 28 over 6 times 8 over 21. Now I could do some cross-canceling here. For instance, I can take a 7 out of 21. That would give me a 3. 7 out of 28 gives me a 4. All right. Now I can take a 2 out of 4. That gives me a 2. A 2 out of 3, and that gives me a 6. Now notice I can't do any more canceling. So this is going to give me a 16 over 9. And if we look down here, we can see some of our answers here. We're at row number 4, and there is our 16 over 9. Okay. Now remember, you can always go back to review these again. Now, in this division, the rule for division is we always change a division of fractions to a multiplication of fractions. So this will be 6 over 19. This part stays the same. We're going to change this division to multiplication. But when we do that, we have to take the reciprocal. That is, we flip this over, and this becomes 13 over 9. Now, that is converted to a multiplication example. We can see if we can do some cross-canceling. 3 will go into there twice. 3 will go into there 3 times. And can we do any other canceling here? Nope. So this is going to be 2 times 13 is 26. And 3 times 19 is 57. 57 here. How about putting that right here? And sometimes I can speak faster than I can write. All right, 57, and that checks out with our answer below. So let's check this next one out. So this is division of fractions. We're going to convert it to multiplication. Change the sign. Take the reciprocal of this. And then now see if we can do some canceling. 3 will go into there once. 3 will go into there 3 times. 2 will go into there 5 times. 2 will go into there 7 times. So we have then 15 sevenths, which is what they have. Now, generally when you're writing your work up, keep your division bars horizontal. Now, if you're typing something out, then you might write it this way. But in your work, as you do your work in the course, keep your division bars, your fraction bars horizontal. Now, in this next part, we're going to add and subtract fractions. The rule is, if you have fractions and their denominators are the same, you would just write the common denominator and then add your numerators. 1 plus 3 is 4. And if you could simplify a little bit, do so. Taking a 4 out of there and getting a 1, a 4 out of there and getting a 2. Now, let me write this one over here. We have 1/6 plus 7/15. What we have to determine here is what would our common denominator be? Because we can't just add the numerators because our denominators are not the same. Now, after looking at that, if you said your common denominator was a 30, that would be correct, because 6 will go into 30 and 15 will go into 30. Now, I'll change colors so you can see this a little better. I want to multiply this fraction by a 1 that will make this an equivalent fraction with the denominator of 30. And that's going to be 5/5. And what form of 1 will I multiply this one by to make it an equivalent fraction with a denominator of 30? And the answer is 2/2. So 6 times 5 is 30, and 1 times 5 is 5. 15 times 2 is 30, and 7 times 2 is 14. This will then give me a sum of 19/30. Now, one of the things I'm doing here is modeling perhaps a method for you to do things like this that's clear and orderly and gets an answer. One of the skills we shoot for in math is your being able to write out things in a clear and orderly way to get your answer. All right, we'll do subtraction now. Well, it's 5/9 minus 1/12. And again, we're looking for a common denominator. Now, you can use that system that we did the other lesson, that first lesson, to figure it out. But I'm going through in my mind, and I end up with 36. Now, what we're looking for is methods to convert 5/9 into an equivalent fraction that has a denominator of 36. What form of 1 will I multiply it by? And if you said 4/4, that is correct. And what form of 1 do I need to multiply this to make it into an equivalent fraction with 36 as a denominator? And if you said 3/3, that is correct. So 4 times 9 is 36. 5 times 4 is 20. Now remember, we're doing subtraction here. This is going to be 3/36. So when I do the subtraction here, I get 1736. And that should be there somewhere. 1736 right there. Okay. Now, this next one's, again, there are various methods. But what we want to do is to add these. So here's how I would suggest. 13 and 2/3. 6 and 5/8. Now we can add these up. This is going to be a 19 here. I get pop-ups every once in a while. But now, to add these two, I have to have a common denominator here. Well, notice, 3 is prime, and the factors of 8 are 2 and 4. So 3 times 8 is 24. That will be our common denominator. Now I have to multiply each of these fractions by 1 to make our new equivalent fraction have a denominator of 24. So this is going to be 8/8, and this will be 3/3. And you may have to fiddle with that a little bit. So I got my 24s. This is going to be 16. And this is going to be 15. So I will now have a sum of 19, and I'm going to put a little plus there. How about 31/24? But this is an improper fraction. So I want to simplify this improper fraction. How many times will 24 go into 31? Well, it will go 1 time, and there is 7 left over. So now I can add 19 in my 1 and get a 20, and then 7/24. And let's see, we are on 6. That's a little further down. Let me move it up here for a moment. And every once in a while I see they have a little error. They got the 20 all right, but this should be 24ths here, as we've indicated. All right, well, let's clear this up and we'll go on to the next one. Now again, different ways to do it, but I might suggest this way. There's my 5, and we want to subtract 2, and then this is 3/7. Now, I don't have any fraction here, but I can borrow 1 from the 5. I'm going to borrow 1. I'm going to go 4 plus 1 from that 5, and that 1 I'm going to make 7/7. So this now here is a 4, so I'll erase that so you can see what I'm doing. So now when I go to subtract this, I can take 3 from 7 and get 4/7. And I can take 2 from 4 and get 2. And that one should be a good one. There it is, right there. Now, when we're multiplying, and these are called mixed numbers because they have a whole number and a fraction. When we're multiplying mixed numbers, and I'll do it over here, what we have to do is first convert this mixed number into an improper fraction. So 3 times 2 is 6, plus 1 is 7 thirds. 6 times 7 is 42, and 3 is 5 sevenths, like so. So let's see here. I forgot to put the 4. There we go. Much better. Now the 7s are going to cancel out. That's a 1. And I get 45 over 3. But if I add up 4 and 5, I get 9. So I know I can take a 3 out of there. 3 goes into there once. 3 goes into there 15 times. So our answer here for this one will be 15. Now, for this one, it takes a little bit of study. This is division. So first, we have to convert this to an improper fraction. 5 times 3 is 15, so this is 19 fifths. 5 times 1 is 5. This is 7 fifths. But that was division here, I should say. We didn't do multiplication yet. So it'll be 19 fifths. Now I change it to multiplication. I flip, take the reciprocal. And then here the 5s are 1. The cents cancel out. And I end up with 19 sevenths. Okay, well that wrapped up this one. This one was a little longer than our 20 minutes. But lots of good background on fractions.